Hello everyone, this is Rahul Shrestha here to present you the 8th and the last part of the chapter matter for class 8. So till now we have understood everything about elements, compounds and mixtures, and very recently until our last video we read everything about atoms and molecules. So each one of these atoms and molecules of different elements and compounds has their own set of protons, electrons and neutrons, have different electronic configurations and has various different types of properties and characteristics. We already know that there are 118 different types of elements and billions of different types of compounds present in this universe. And all this information took humanity hundreds of years to gather. Now the thing is that this much tremendous amount of information can be really cumbersome or confusing for people to study, understand as well as remember. So we needed a proper systematic approach to solve this problem. And in order to combat this problem, what we did was we started to organize these elements. Organizing simply means to arrange. So we started arranging these elements, but arrangement is possible only when we categorize these elements. This is how we organized the elements, and this organization helped us study these elements very easily. What we actually did here is that we classified these elements into various groups. Classification of elements is categorizing the various elements into groups based on the similarities and differences in their properties. This classification helped us in grouping the various elements into different categories, which we refer to as periods. And so this system is also known as the periodic classification of the elements. And this periodic classification helped us get the most important base for studying chemistry systematically using the modern periodic table. But this modern periodic table was not our first attempt in categorizing the elements. Rather, this table is the result of several past attempts of classification by various past scientists. It first started around the 19th century when a famous German scientist named Daubigny tried classifying these elements into groups of 3 elements. He classified these elements in such a manner that the average of the atomic number of the first and the third element gave the atomic number of the second element. But this system of classification was not perfect, as all elements known at that time did not follow this rule. And later, with the discovery of other new elements, this system didn't really work. So after grouping the elements in a series of 3, a newer system of grouping the elements in a series of 8 was developed by a scientist named John Newland in 1866. He arranged the 56 elements known at that time on the basis of their increasing atomic mass, and what he noticed that every 8th element in the group resembled the first. Much like the octaves in our music, where every 8th note is same as that of the first one. So this was how he arranged the elements in the table. If we consider lithium as the first element, then the 8th element after it, which is sodium, had a lot of similar properties with lithium. And this was true for most of the other elements in this table as well. And so he named his grouping system as the Law of Octaves, which later came to be known as Newland's Law of Octaves. Although this system was quite good, but it was only valid up to calcium and was not applicable to elements after that. By that time, only 56 elements were known, and Newland assumed that no new elements will be discovered in the future. Of course, a lot of other elements were discovered, but none of them could fit the system. There were some more shortcomings in this system, and that is why this system was also ruled out. Later, a much better and well-defined system was put forward by a Russian chemist named Mendeleev, who gave a systematic approach to classifying elements. And his classification also formed the foundation of the modern periodic table. There were almost 63 known elements when Mendeleev did his classification, and in order to simplify his process, he wrote all the physical and chemical properties of each element on 63 different cards. And then he arranged these cards on the basis of their increasing atomic masses. After this arrangement, he had some surprising observations. One was that there were a few empty spaces left in the table, which he believed to be the places of the elements which were not yet discovered. But he had a firm belief that the missing elements did exist and will be discovered in the near future. He was so confident with his belief that he even predicted the properties of these missing elements well in advance, which even came out true, as the elements which were discovered later were almost a perfect match with the properties given by him. Second observation that he had was the reoccurrence of the chemical and physical properties. After arranging the elements based on the increasing atomic mass, he observed that the chemical and the physical properties of the elements reoccurred after a particular interval, and so he came up with a law known as the periodic law, which stated that the properties of the elements are periodic functions of their atomic masses. Now let's try and understand this law first. Properties of elements means the physical and the chemical properties of the elements. Are periodic functions means those which appear at regular intervals. And then of atomic masses means when arranged on the basis of their increasing atomic masses. So we can say that when he arranged the elements on the basis of the increasing atomic masses, the elements showed similarities in their physical and chemical properties at regular interval. And this is how Mendeleev laid the foundation of the modern periodic table. But his system of classification did had some limitations as well. Like for instance, Mendeleev was quite skeptical regarding the position of the element hydrogen in his table. If we look at the table, hydrogen is placed in group 1 along with other alkali metals because it had similar properties. But hydrogen also has properties similar to the elements in the 7th group, which are known as halogens. So where should we put hydrogen? Is it in group 1 or group 7? This was the first limitation of his table. In the same manner, if you look at the element cobalt here, Mendeleev placed cobalt a position higher to the element nickel. Although cobalt has a high atomic mass and should be placed after nickel, but he did so in order to keep the elements with similar properties in a single group. Here, cobalt shows properties similar to the element rhodium and iridium, which is below it. Nickel, on the other hand, showed properties similar to the elements peridium and platinum, and so was placed above them. He made such exceptions in his table when an element with higher atomic mass comes before an element with lower atomic mass, contradicting his own periodic law, and this contradiction was another limitation of his table. Even though his table was quite well defined, but it wasn't the best table ever. As with time, when we discovered more new elements, fitting them into the table according to the periodic law given by Mendeleev seemed difficult. So, with the discovery of more and more elements, it became difficult to study these elements. Until in 1913, when a British physicist, Henry Moseley, found out that instead of atomic mass, all the elements will show periodicity when arranged in the increasing order of their atomic number. And with this discovery, we got our modern periodic law, which stated that the properties of the elements are the periodic functions of their atomic numbers. This law was quite similar to the previous law proposed by Mendeleev. Here, the physical and the chemical properties of elements occurred periodically, but when arranged in the increasing order of their atomic numbers rather than the atomic masses as proposed by Mendeleev. With this, predicting the properties of yet to be discovered elements got simpler and precise, and it also helped in placing the newly discovered elements in the periodic table properly. This law also helped in overcoming the limitations of the Mendeleev periodic table. And because this table was based on the modern periodic law, the table was named as the modern periodic table. This table has all the 118 elements discovered so far, and their respective positions are laid out in different groups made inside the table. Starting from the very left, we have the soft, very reactive, active metals, which are so reactive that we have to store them in inert gases or oils to prevent them from reacting with the environment, and we never find them lying around us in their elemental form. Next, we have the alkaline earth metals, reactive metals but not as reactive as the alkali metals. The middle body of the table is filled up with the transition metals. These basically consist of the metals which you actually consider as metals like iron, copper and gold and platinum. They are fairly unreactive but great conductors of heat and electricity. Then on the far right of the periodic table, we have the noble or the inert gases. The shells of these elements are completely filled and they never take part in the chemical reactions. Then the column just next to the noble gases contains the halogens, which are highly reactive nonmetals containing 7 valence electrons, and they love to react with alkali and alkaline earth metals. Then the rectangle between the transition metals and the halogens contains a set of metals, metalloids and nonmetals. These are generally a bit less reactive lot. Down below on their own little island are the lanthanides and the actinides, metals that were largely undiscovered during the Mendeleev's days. Now, a modern periodic table can give us a lot of information regarding an element. For instance, apart from telling us whether an element is a metal, non-metal, halogen or noble gases, it also tells us the atomic number and the atomic mass of each element, which help us determine the electronic configuration of any element. The periodic table is arranged in periods and groups. The rows going from left to right horizontally are the periods. There are in total 7 periods in the modern periodic table. Elements in the same period have the same number of energy shells. Each new period row represents a new shell. Elements in the first period has 1 shell. Elements in the second period has 2 shell, and so on. As we go down, the shell increases. Hydrogen is in the first period. It has 1 shell. Potassium is in the 4th period. It has 4 shells, as well as all the other elements in the same period. The columns going down from top to bottom are the groups. There are in total 18 groups in the modern periodic table. Elements in the same group has the same number of electrons in the outermost shell, known as the valence electrons. These valence electrons are the ones which take part in the chemical reactions and are the reason behind the reactivity of any element. And this is why the elements in the same group has so much similar properties with each other. The group number can tell us how many valence electrons are in an atom. For example, let's look at group number 7. Fluorine, chlorine, bromine, iodine, etc. all have 7 electrons in the valence shell and all has similar chemical properties. Now if we look at the period again, we'll see that each elements here belong to a different period, telling us that each elements in this group has its outer electrons in a different shell. So chlorine is in group 7 period 3. Therefore, it has 3 energy levels with 7 electrons in its outermost shell. So this was all about periodic table that I wanted to discuss with you all. I'm done with today's class as well as the chapter. Your forthcoming classes might be conducted by some other teacher. Please do remember to learn the first 20 elements well. Until next time, take care and be safe. Thank you.